Heat treating is a group of industrial, thermal, and metalworking processes used to alter the physical and sometimes chemical properties of a metal. Heat treatment involves the use of heating or chilling, normally to extreme temperatures, to achieve the desired results, such as hardening or softening of a material. It is through the working combination of time, temperature, and technique that determines the properties you want in a piece of metal.
But that's the scientific answer. This is what it means in your world. Check this out.
Heat treating is what fires the space shuttle into orbit for scientists to explore the surrounding planets. Heat treating allows planes to safely take off and land every day for vacations and business travel. Heat treating ensures elevators safely go up and down in tall buildings, allowing people to live and go to work. Heat treating powers transportation in cars, trucks, buses, and semis to keep them working. Heat treating powers the computer's electronics to connect to the internet. Heat treating strengthens the medical devices that give freedom to those that need medical assistance. You see, where there is metal, there is heat treating to improve a metal's strength, hardness, toughness, ductility, and corrosion resistance. The exciting thing about heat treating is it involves all sciences, including engineering, physics, chemistry, mathematics, material properties, just to name a few. You use those sciences to change a material's property through numerous types of processes, including annealing, hardening, surface treatment, and tempering. Metals are heat treated in these processes in small to very large furnaces like vacuum, induction, flame hardening, batch atmosphere, brazing, continuous furnaces, plasma, and even cryogenics.
To connect the dots on heat treating, let's take a look at an example in the shop floor.
Let us start with an item that almost everyone uses, a gear that forms part of the automatic transmission in your car. In order for these gears to function properly inside your car or truck and not break upon your engine turning on, they require heat treating to make the surface hard and wear resistant, and the core tough. These gears are received from the facility that machines them prior to heat treating and are loaded into special fixtures for heat treatment. The load is then charged to a furnace and heated to a specific temperature. While in the furnace, the parts are exposed to a specific atmosphere that modifies the surface chemistry of the parts, that aids in what is called carbon. This will ultimately generate the desired properties on the surface of the transmission gear to make the surface hard and wear resistant, and the core tough. The parts are held in the furnace for a specified time by the metallurgist, and then the parts are transferred to the quench to freeze the modified microstructure that will ultimately develop the end-use properties of the gear. After the quench process, the parts are washed to remove any excess quench liquid, and then given a second, lower temperature heat treatment called tempering to set the final properties required for the gear. After tempering, the parts look the same as they did prior to heat treat, but their properties for hardness, toughness, and ductility have all been modified to meet the end-use application for the gear. Once completed, the heat-treated gears are loaded into containers and shipped off for final grinding and assembly into transmissions for installation in cars. Without heat treating, cars would not drive, planes would not fly, elevators could not rise, and medical devices would not function properly. Heat treating impacts society everywhere, every day. Because where there is metal, there is heat treating behind it.